any programming or coding to be developed, you need to know the flow in which it needs to be processed or proceed with. Am I right? So here logic gate, in the earlier session we were discussing about data communication, and data communication is possible by means of signals. Whenever we are talking about signals, signals are of two types. One is analog signal, the other one is digital signal. So analog signals are continuous in nature, whereas digital signals are discrete in nature. If anyone asking me time now, I can say like it is 11:10. I don't know whether it is 11:10 accurately or not. It can be even 11:11 or 11:09 with something. Whereas digital clocks or digital information are accurate in nature. To achieve this accuracy, we are in need of some elements. Actually, before starting with logic gate, we need to discuss about evolution of computers. Evolution can otherwise even it can be called as history of computers. So it starts from 1G, then 2G, 3G, 4G. Please don't surprise with the mobile technology 1G, 2G, 3G. This is first gen computer, second gen computer, third gen. Okay. The first gen computers have been made up of diodes, resistors, transistors, some digital elements. Physics students might be knowing little more extra stuff related to that. Digital elements. Coming to 2G, in addition to this, they actually this is 2G, 1G is with vacuum tube, if I am right. Vacuum tube, this is 3G, 4 and 5G, it moves on. So second generation is with the digital elements and third generation is with IC. IC is nothing but integrated circuit. I can find some of the girls are taking running notes. Some of the girls are simply sitting and watching. Please have the habit of taking running notes. And fourth generation onwards, actually the processors came into existence. And fifth generation onwards, higher level processors. So it starts from 4 bits and now it is 128, 256, it is going. Okay? So we are about to discuss about, without taking off this digital, nothing will be happening. Throughout all this first gen to current gen, recent gen, everything is possible by means of logic gate. Okay? So, as some of you suggested, what are all the logic gates available? So, the prime logic gates available is, and you have AND gate, OR gate, NOT, XOR gate. The prime gates are this only. 4 gates are the prime gates. Your NAND, NOR or NOR, XNOR and all, the combination of these things. Let's discuss later. Now, I am going to give the consolidated view of all the gates. This is logic gate name. And next column is going to be symbol associated with that. What else I need to? Logic circuit. And then truth table. I don't know how I am going to accommodate this truth table, let me see. So AND gate symbol, AND is Logically speaking, and will perform dot operation, that is multiply operation. And OR is plus operation, that is add. It will do add. And NOT is, you can even show like tilde symbol or exclamatory mark or even 7 symbol. All can be used interchangeably. And NOR is, XOR is, you should have a plus with the circle. Fine? Actually, all these chips have some IC numbers. Say for example, for AND expression, if I write 7032 something, I'll get the chip numbers later. Okay? For NAND, it is 7332 if I'm right. So that we'll discuss later. The symbol associated with AND is what? A D like symbol, a D, capital D like symbol. And for OR, like this, arc with that shape. And NOT is a triangle and a bubble, and XOR is again with one more arc, the same arc symbol. Make a note, not alone, not gate alone, single input, one input. Rest of the things will work for two inputs. Okay, so the logic circuit we will talk about with, we need to discuss with the number of inputs. You have A and B, whenever you are supplying, then this will return A dot B. And then if it is R, the logic circuit associated with that is same input A plus B. Here only we need to know, for NOT gate, it will do the complementing option. If you say yes, it will return no. If you say no, it will return yes. Just a complement value. So only one value is possible. So if you say yes, yes my dear.
Below the OR code is not visible, ma'am.
Now, okay?
Yes, ma'am. Now it is visible.
Okay. For XOR also we need to supply two inputs. A exclusive or B. Okay? Truth table. I say some baby is in between teaching, check, and online. This I'm taking for and this I'm taking for OR, and for NOT, and for XOR. So what are the input values? A, B, A dot B. Again A, B, A plus B. And for NOT, A and A dash. This bar also you can take. And XOR A, B, A exclusive R, B. Got it? Since we are talking about two values, the combination of the two values to be taken. So what are the basic, for binary which values are supported? It is 0 and 1. So the possible combinations are 2 square, it is 4. From 0 you need to take 0, 1, 2, 3. But binary equivalent we need to take. Throughout whichever topic we are discussing, we will be working it out in binary form. Okay? So for AND gate, first 0 is, it is 0 and 0. To represent 1, 0 and 1, and to represent 1, this is 0, 1, 2, 3. So what is 2? 2 is nothing but 1 and 0. So this 1 and 0 to be taken, 1 and 0. What is 3? So it is 1 and 1. Okay? So simply do the multiplication. Anything into 0, you will be resulting with 0. And 1 into 1, it is 1. And whenever we need to perform A plus B, what we need to do? We need to add the input values. So it is 0, 1 plus 0 plus 1 is 1, 1 plus 0 is 1, again 1 plus 1, 1 only you need to put it. Okay, that is logical AND operation. Coming to this NOT gate, if you send or supply 0, you will be getting 1. And for 1, it will return 0. Simply, that's it. No more operation. Coming to XOR. XOR alone, it has got some specific usage here. I don't know, if you want, you can put a note in your notebook. To clear the processor or accumulator in microprocessor based operation, they will perform this XOR. XOR what it will do, whatever it may be the content, it will clear the accumulator, like initializing the accumulator or processor. It will be used, it has got some specific use, and the normal addition is possible by means of XOR gate only. Whenever we are discussing about full adder, we will come to know. Okay, that's a special about XOR. So how the XOR gate is actually functioning is for identical values. I am telling the input. For identical values, it will return 0. For alternate values. So for 0 and 0, XOR will return 0. For 0 and 1 and 1 and 0, alternate values, it will return 1. Again, 1 and 1 are identical, it will return 0. Got it, all of you? XOR operation. XOR is a special logic gate. It has got widespread applications in digital circuits. Right? So, as some of you listen, we may have immediate discussion can be done with X0, and you have NAND, and you have NOR. XNOR is NOT plus XOR. NAND is NOT plus AND. And NOR is NOT plus OR. It's simple. Okay? So how to fill up the truth table now? Simply the complementary values of XNOR can be derived out of XOR on complementing its truth values. Am I right? Am I right, all of you? XNOR is nothing but complement the XOR because you are adding a NOT. So if it is 0, 1, 1, 0, XNOR will be coming out with 1, 0, 0, 1. Complementing XOR will give you XNOR. Same logic applicable for NAND. Complement the output values of AND. So it is 1, 1, 1, 0. And complement R. What is R here? It is 0, 1, 1, 1. It is 1, 0, 0, 0. That's it. Take down neatly. This may be the 1 10 mark or descriptive question. Running notes can be as it is. If time permits, you please pair the stuff with the functionality. Whatever I have explained right now, same way you can explain the functionalities associated with the gate. So make a note, these are prime logic gates. Supposing if the question is asked, explain about logic gates, you can very well explain only AND or not XOR. You need not touch XOR, NAND or not. Because prime logic gates are this, rest of the gates can very well be derived from those prime gates. Fine? You finish up writing all of you, taking down, then I'll tell something else. Can anyone ready with the syllabus? Yes. Your big name, my dear? Enama? Pravina. All of you completed? So don't forget XR. Even in competitive examinations like NET, SET, GATE, they are asking the functionality of XR. You should not confuse. Simply identical values it will return 0. Alternate values it will return 1. Have that in mind. Simply. Shall we move? Okay. I have something to highlight about this NAND and NOR. Even computer science girls might have come across. NAND and NOR are said to be universal gates. NAND and NOR gates are said to be universal gates. Why? Because with these two gates, you can design or configure AND, OR, NOR and XOR. Reverse it. By using NAND and NOR, you can very well develop or design AND, OR, NOR, XOR. In that way, these two gates are termed as universal gates. Even in the part A question, section A question, they will ask like, what are called universal gates, or what is the reason to be called as universal gates? You need to tell like NAND and NOR are universal gates because rest of the prime gates can be derived out of these two. Simply. Fine? Any doubts till that? It's simple only, right? So next class, whenever before we are commencing with the class, I'll be posing some questions related to it. So whichever you had registered from that, recall and you please come out with your responses. Right? So the fourth component in CIA, continuous internal assessment, we need to monitor right from day one how interactive you are, how well you are responding. Why I am telling so? For which your 100% attentiveness is needed. Accordingly, you can be able to respond. No matter whether you are coming out with the right answer or not, feel free to interact and if any doubt also, for any doubt clarification. Shall we move on? Online girls?
Yes, ma'am.
Ma'am, at the corner of board is not
Yes.
possible, ma'am.
Which one? Corner of board?
And get
Corner of
non get, ma'am.
land and north.
Yes.
One of you take this happen, sir. It's away. Classroom. Please wait. It is add in the classroom. Then மொத்தமாவே எடுத்து ஒரு இது போட்டுடலாம். Then we'll rub it off. It will be shared in the classroom now. Afterwards, I'll clear the board and we'll move on.
Okay, ma'am.
Any doubts, my dear?
No, ma'am.
Okay, I'll rub the board.
It is not visible. The board